All right, let's continue with the DCA review. This next problem shows a pair of parallel lines. Again, I know they're parallel because of those extra set of arrows you see over here. And we have this angle in this corner and this angle in this corner. Those two angles are on the same side, same position, so they're corresponding. And we know that if the lines are parallel, corresponding angles are congruent. So we're going to write an equation to solve for x, and we're going to set it up as angle equals angle. So that means we're going to write 5x minus 6 equals 4x plus 10 to solve for x. So the first thing I would do is subtract little brother 4x from both sides. And when you do that, you're left with x minus 6 equals 10. And then I would add 6 to both sides. So you would get x equals 16. And you're done. This problem would like for us to determine the distance between the 2 points. On your formula chart and in our notes on distance, the distance formula is a little complex when it's on a coordinate plane. But this a somewhat simpler version is simply taking the square root of x minus x squared and y minus y squared. So you need to identify the coordinates of each point. So this point is at negative 6, positive 2. This point is at 5, negative 2. 1, 2, 3, 4, 5. So you would find the distance by putting the two x's together and the two y's together, finding the difference between them. So the two x's are negative 6 and positive 5. The two y's are 2 and negative 2. So that's one way. Another way, when you have the actual graph itself, is to form a right triangle. Sorry, it's not the best right triangle, but it should be better if you actually have pencil and paper. When you form your right triangle, you simply now need to count the side lengths of the straight sides. So the one on the left is 4. The one running across should be 11. And then essentially we're trying to find the last side of the triangle. And we can use Pythagorean's theorem to do that, because Pythagorean's theorem says a squared plus b squared equals c squared. So c is the missing side. And then, so we're looking for c, and we have both a and b. So the short version would be c is equal to a squared plus b squared, and the square root of that. So keeping that in mind, a is 4, and b is 11. And you would have found this out as well if you continued with the distance formula in red at the top. But just in case you didn't do it properly, this is another way to demonstrate it or check your work. Take it in steps. 4 squared is 16. 11 squared is 121. Combine 16 and 121, you get 137. So you could leave your answer just like this. This is a perfectly great answer. The square root of 137. Or you can grab your calculator and type in the square root of 137 and see what we get. So let's grab our calculator real quick. So it's second x squared and then 137. And you would get approximately 11.7. So had you typed in the red distance formula correctly, you should have gotten 11.7 as well. If you didn't, something was entered incorrectly. You need to go back and see what part was entered incorrectly. Because you can enter all of this in red at the top in one step, but you have to be very careful because you will get a wrong answer. If any sign is missing, any parentheses are missing, and so on and so forth. Alrighty, on this one, it wants us to write a biconditional for each of the following conditionals. This is from Unit 2, Day 2. A biconditional has the format P if and only if Q. So let's identify our P and Q from the statement first. P is your hypothesis. Q is your conclusion. The hypothesis is always after if. So on number 1, the hypothesis is today is Monday. That's P. Your conclusion always follows the word then. So our conclusion on number 1 is tomorrow is Tuesday. That's Q. So when I write the biconditional, you're going to say today is Monday, if and only if tomorrow is Tuesday. So same idea for number 2. Identify P and Q. P is you are reading this. Q, you're in math class. So the biconditional should say you are reading this if and only if you're in math class. Oh my gosh. Sorry. Something copy that wasn't supposed to. Let's go ahead and get rid of that. So on number 3, the biconditional would be you are happy if and only if you had a good day. So P if and only if Q. To write a contrapositive, it was the statement where we said not Q, then not P. So in the original sentence, P is, on number 1, it is after school. Q is there are tutorials. So when you look at P and Q, we have to add not to the verb. So I need to put is not and are not. Not only do I add not, I have to switch the order where Q has to come first in the statement. So the contrapositive would read, if there aren't any tutorials, then it isn't after school. And there's other ways you could word it, but it's essentially saying the same thing. All right, for this next one, P is x equals 3. Q is 2x plus 4 equals 10. So you could still, what the statement is saying is x does equal 3. So if I have to add not, I could say x does not equal 3 in words, or in symbols, you simply just slash the equal sign to mean not equal. And I would need to do the same thing with q, slash it. When I slash it, it means not equal. And then you have to switch the order, have q come first. So it would read, come on, disappear. Okay, it doesn't want to. If 2x plus 4 does not equal 10, then x does not equal 3. These next set of questions would like for us to determine the validity of this conditionals, and if it is false, provide a counterexample. So when it says determine validity, that means, is it the statement true or is the statement false? And again, if it's false, you got to give an example or a reason why it's false, and that's a counterexample. So the first statement says, if you are in Nimitz Senior High School, then you are a sophomore. In order to say true, it has to always be true. So read it again. If you are in Nimitz Senior High School, then you are a sophomore. Is that true always? No, it's not. It's false. What's one reason, just any one reason why this statement could be false? You could be a freshman. We do have freshmen on our campus. You could be a junior. You could be a senior. It just says you are in the high school and you are a sophomore. It could be a custodian. It could be a principal. So there are several reasons why this is false. All you need is one. And to make sure, again, in order to be true, it has to be true always. Number 2 says, if A, B, and C are collinear, then B is the midpoint. So let's recap what collinear means before we go further. Collinear means that they're on the same line. So A, B, and C are on the same line. So I have 3 points on the same line. And the statement is saying B is the midpoint. Is that true all the time? No, it's not. This is also false. I could have my points in order like this. A, C, B. That is still collinear. B is not in the middle. I could have it as C, A, B. Those are collinear. But B is not in the middle. So that's 2 perfectly good counterexamples. 2 reasons why that statement is false. I could even draw it where B is in between, but it's not in the middle. That's a third example. I could put A, B, C. B is between it, but it's not in the middle. The reason it's not in the middle is because the distance from A to B is 2. The distance from B to C is 6. So those distances aren't the same. So that's another reason why it's false. But again, all I needed was one reason to prove why it was false. And I've given you several. All right, this problem set wants us to find the midpoint. So we're going back to our distance and midpoint notes from Unit 1. To find the midpoint, the formula from your formula chart is essentially x plus x over 2, y plus y over 2. So I'm going to find the midpoint between A and B. I always say write your formula skeleton first before you insert any values so that you know where to put the values. Your x's have to go together, so my x's are -4 and 2. And then your y's have to go together. You cannot mix the two. Y's with y's, x's with x's. And now simplify it in stages or using your calculator. So -4 plus 2 is going to give us a -2. -6 plus 6 is going to give us a 0. -2 divided by 2 is -1. 0 divided by 2 is 0. So the midpoint is -1, 0. Do the same thing for number 2. Same formula, same skeleton. This time the x's are -10, +4. And the y's are +4, -8. So -10 plus 4 is -6. 4 plus -8 is -4. -6 divided by 2 is -3. -4 divided by 2 is -2. So the midpoint is -3, 2. And we're going to pause right here and resume in just a moment. Nah, let's keep going. I'm sorry. Because the next one is similar to this question. This one is saying find the missing endpoint. So on this problem, we have a segment EF. Where D is the midpoint. Because that's exactly what it says up here. D is that point in the middle. Our job is to find the endpoint that is missing. So number 1, they give us D, they give us E, so that means we have to find F. On this one, I would use the EME method. Endpoint, midpoint, endpoint. The endpoints are E and F. The midpoint is D. Okay, write what we know, what is given to us. They told us E is -24 and D is 0.6. So now find the pattern so that it'll be consistent so we can find F. To get from -2 to 0, you have to add 2. To get from 4 to 6, you also have to add 2. So your y's and your x's both add 2. So keeping that same pattern, F will be located at +2, +8. All right. On number 2, they give us F and they give us D. But it's still, we're going to use E and E. We got F, we got D. We're looking for E. F is -5, 1. D is -3, -3. Again, establish the pattern so we know how to find point E. So we're going from -5 to -3. So that means you add 2 to your x's. We're going from +1 to -3. So that means we subtracted 4 from our y's. So our x's are going to add 2 all the way. Your y's are going to subtract 4. So that means we can find E. So -3 plus 2 is going to be -1. -3 minus 4 is -7. So E is at -1, 7. And now we will take our break and resume with the rest of the review in just one moment. Stop.